Radius of the unit circle or a circle. So if you know your Sakatoa that way, whatever. Sakatoa. Anyways. Sine theta would be opposite over hypotenuse or y over r. They're both positive. R is always positive. Why? Why is R always positive? It's a radius. It's a length of a line going from the center to the outside of the circle. It's always positive. You can never have a negative radius, right? So this is positive. Yes? Cos theta is adjacent over hypotenuse, so x over r. So that's positive as well. That doesn't look like a positive. I'll rewrite that. Then we have tan, which is opposite over adjacent, which is y over x. So that is also positive divided by a positive is a positive. So in the first quadrant, okay, do you remember reference angle and related angles? In order to solve trig equations, where angles are between 0 and 360 degrees, the reference or related angle will be used. So here's a little refreshment on reference angle. Reference angle is an acute angle formed between the terminal arm and the nearest x-axis. The related angles are generated from the reference angle. For example, say my reference angle is 20 degrees. I'm just making this up. We're saying it's 20 degrees. So where would it be in the first quadrant? Well, there would be my reference angle of 20 degrees? Well, what's kind of neat about the first quadrant is that's also what my related angle is. They're the same. Okay, so now if I draw my reference angle in the second quadrant, theta r equals 20 degrees, what would my related angle be in that quadrant? Not 110. 160, very good. How do I get that? It is 20 degrees short of 180. Remember this? Okay, third quadrant, my reference angle again is 20 degrees. What is my related angle? 200, very good. How did I get that? 180 plus the additional 20. And then we go to the fourth quadrant. Here is my reference angle of 20 degrees. What would my related angle be in the fourth quadrant? 340 degrees. How do I get that? It is 20 degrees short of the 365 going all the way around. Make sure you are putting degree symbols. Why? Besides being a half mark deduction, if you don't, it means it's in radians. Yes. So, when finding theta, given theta r, what do you do in quadrant 1? I don't like how it's labeled. Did you know that quadrants are actually Roman numerals? I mean to fix this. Did I fix it on yours? If it didn't, make this Roman numerals. It should be like this. I like doing proper math, so let's just fix this up. Okay, so how did I find the related angle in quadrant 1? Well, the related angle was the reference angle in quadrant 1. How did I find theta in quadrant 2? Yes, 180 minus the reference angle. How did I find the related angle in quadrant 3? Yes, 180 plus the reference angle. And how did I find the related angle in quadrant 4? 360 minus theta r. Don't ever look at the y-axis. Reference angles are always respect to the nearest x-axis. Okay, here's something new. Grade 12, coterminal angles. Coterminal angles are angles that share the same terminal arm. So, for instance, 100 degrees, 460 minus 260. Oh, before I go into coterminal angles, does anybody know why reference angles and related angles, like what's the big deal about them? What's the big deal about them? Like what's the like why do I care that I have certain reference angles and all these related angles? Yes, so it has to do with, say for instance, say I know sine of 20 degrees is blah, blah, blah. I also would then know that sine of 160 degrees would be the same blah, blah, blah. Yes? Sine of 200 degrees would now be negative blah, blah, blah. The same thing, but the sign changed. Why? Because I'm now in the third quadrant. Yes? And in the fourth quadrant, sine of 340 degrees would be the same blah, 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 but because it's in the fourth quadrant, it would be negative blah, 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 right? Okay, so I don't know what sine of 20 degrees. I'd have to grab my calculator. That's why I'm saying blah, blah, blah. Yes, I'm saying it on the recording. Okay. So why do I care about coterminal angles? Well, look, here is 100 degrees. Here is 460 degrees. You always start on the initial side. And what is the initial side? The positive x-axis. So how would I get 260? I start on the initial side, but this time because it's negative, I am going this way around. Okay, notice They all land in the same spot. That's the significance between coterminal angles. So for instance, cos of 100 degrees would be exactly the same as cos of 460 degrees. It would also be the same as cos of negative 260 degrees. So how would I actually find my coterminal angles? Well, to find a coterminal angle, we are going to add and subtract multiples of, what did I do here to get from here to here? We added 360. What did I do to get from 100 to negative 260 degrees? I minus 360. Okay, so moving on. How would I figure out the positive coterminal angle in the first positive revolution if my angle is negative 130 degrees? What do I do? So 230 degrees is the positive coterminal angle to negative 130. How about 480? I would subtract 360 degrees. So that would be 120 degrees, yes? Okay, what do I do here if I have negative 450 degrees? Add 360, add another. So what could we have done in the first place? Add 720 degrees to it. That's two multiples of 360, right? So that would be, what's that? 270 degrees is the positive coterminal. Anybody do skateboarding, skiing? You do the 360s, 720s, what's the next one? Next revolution. Huh? 1080. What would I have to get rid of here? 1080. That's 3 revolutions worth. Or you could just keep on subtracting 360 until you get an answer between 0 and 360, right? So what do we get there? Actually, it gets 60 degrees, yes? Okay, now we're going to state all the coterminal angles from negative 360 all the way up to 720. So let's grab our calculator just for fastness. Okay, so 220. If I want to go to the negatives, what would I do? Subtract. So 220 subtract 360, I get negative 140 degrees. Okay, now I'm going to go into the positives. How would I get something after 220? Add 360. What do I get? 580 degrees. Negative 300 degrees. What should I do there? Add 360. What do I get? 60. I have as small as I can go with the negative 300, so I add 360, I get 60. So I would keep the 60 and add 360 because there's no sense going back to a negative. We get 420 degrees. Do I need to add another 360 degrees? No, it'll be too big. Okay, 240, what do I do to get the lowest one? Minus 360, I get negative 120. I could keep 120 and add 360, but then I'd be at 240 again. So why not just start from 240 and add 360 to it? I get 600 degrees. Are we okay? Okay, let me finish the last one. This one's way too big, so that's not even one of the coterminal between those. So how would I start this one off? Minus 360, I get 780. Is that in that domain? No, keeps going. Subtract 360. We get 420. Subtract 360 again, I get 60. Subtract 360 again, I get minus 300 degrees. So example 3 is the first kind of taste of an infinite number of solutions, and that is where we add in this little k dealie here. Do you remember when we were doing set notation and I said you need to say x is an element of reals? Guess what k stands for? It does not stand for real numbers here. When I added and subtracted multiples of 360 here, what was I multiplying 360 by? Well, it could have been 0 and I didn't do anything to it, and that's how I got 220. It could have been minus 1, and that's how I ended up getting subtract 360 for this. It could have been k is 2, and that's how I added 720 to get 580. So k is actually an element of integers. This fancy little z. It's got a double line on the diagonal there. It's kind of like, you know how we had real numbers that had the double? It's just math font. Math font. Okay, so if I want to generate an infinite number of coterminal angles at, let's say, 220 degrees, all I would do is take 220 degrees and add multiples of 360 degrees times k. From the previous example in A. So I could take negative 300. I'm going to take 60, and I'm just going to say 60 degrees plus 360 k. That will generate all the answers. And again, I'll repeat. If k is an element of integers, integers is the set of ... negative 3, negative 2, negative 1, 0, 1, 2, ... forever. Does everybody understand that's what integers is? So what I am in fact doing is I'm taking the 60 degrees and I'm adding some integer times that. So if I say start at negative 3, okay? Well, let's do something easier, negative 2. Negative 2 times 360 is negative 720. If I take 60 degrees and minus 720, I will get a coterminal angle. If I put 1 in, negative 1 in, I'll get 360 times negative 1. That means 60 subtract 360, I'll get my other coterminal. If I put 0 in for k, 360 times 0 is 0, and 60 plus 0 gives me that 60 that was there originally. If 1 goes in there, 360 times 1 is 360, and I add 360 to 60, and I get my next coterminal. Do you see how this list generates an infinite number of coterminal angles? It's forever. Yeah. So C would just be 240 plus 360 degrees K. All the integers, not real numbers, integers. That's what K stands for. D would be, let's say, 60 plus 360 K. So for this question, we'll need our calculator. Before I go further, has anybody ever heard of Pythagorean triples? Okay, who can name some Pythagorean triples? 3, 4, 5 is the most famous. What the heck?